Hi, this is Siam. In this video, I'll show you how to find where a function is increasing and decreasing using derivatives. So my example here is x cubed minus 3 over 2x squared. And we'll go step by step to find where the graph goes up, where it goes down, and where the relative maximum and minimum can happen. Okay, to figure out where a function increases or decreases, we use its derivatives. And the derivative tells us the slope. The positive means the function goes up, and the negative means it goes down. So let's first find the derivative. So the derivative here is 3x squared minus 3x. And if you look at both these terms, they both have 3x, so we can factor it out. X minus 1. So next we'll find the critical numbers. These happens where the derivative is 0 or where the derivative doesn't exist. So here we have 3x times x minus 1. We will make that to 0, which gives us x is 0 and 1, since that's where it'll be 0. I'll make a mark of that. Okay. Now we test the signs of the derivative in the intervals made by these 0 and 1 points. So this is our chart, intervals, and we'll first grab our first term, 3x, and oops, x minus 1, and our first derivative, and our function. So let's first put our intervals negative infinity to 0 and 0 to 1, since these are our critical numbers, and 1 to infinity. So if we insert a negative number or 0 here, it turns into negative. So I'll change a different color for this. Negative. And if you do the same thing here, negative minus 1 is just negative. So negative times negative is positive. So the function here is increasing. And 0 comma 1, 3 times 0 is 0, 3 times 1 is 3, so it's positive. Same thing here, but 0 minus 1 is negative 1, so it's just negative. So positive times negative is negative, decreasing. So for our last one, 3 times 1 and positive numbers, so it's just positive. And then here, same thing, so it's increasing here. So let's make a number line based on this. We'll have our function here and our derivative here. And since our critical numbers are 0 and 1, let's just mark them like this. And this is where our function is 0, also here. And here we have negative infinity to 0 is just increasing. Here it's decreasing, here it's positive. So therefore it's increasing, decreasing here, and increasing here. Now it's increasing here, hold on. It's increasing here and decreasing here, so there has to be a relative maximum here. So when the function is 0, it's going to be something here, which we'll do later. And same thing here, it goes from decreasing to increasing, so there's a relative minimum here. So let's find these points. Okay, to find our points where there's a relative minimum and maximum, let's bring back our original equation. So we find that at when x is 0, there's a relative max. And when x is 1, there's a relative minimum based on the previous chart. So let's insert these numbers. So when f is at 0, it's 0 comma 0, and when f is at 1, you get 1 comma negative 3 over 2. So yeah, this is the relative max and relative minimum. So I grabbed the graph from Desmos for this equation. And here, as you can see, we can find the relative maximums and the minimums right here, relative max and relative minimum right here. And based on our previous chart too, we can see that from negative infinity to 0, it increases here, and from 0 to 1, it decreases, and again, from positive 1 to infinity, it increases. Yeah, and that's how you analyze increasing and decreasing functions. Thanks for watching.